All right, welcome back. For this next example, it's pretty much the same as what we did before, but there's a little bit more as far as stepwise, and I do want to walk you through how to do this on a graphing calculator. So we are talking this time about the level of blood glucose in diabetes and their correlation. So if X is a random variable, measure milligrams of glucose per deciliter. After a 12-hour fast, the random variable X will have a distribution that is approximately normal with a mean of 85 and standard deviation of 25. And this is for adults under 50 because once you turn 50, these numbers start to change. So after a 12-hour fast, what is the probability that an adult under 50 years old will have X as a random variable be more than 60? So first things first. Mu for this example is 85. Sigma is 25. So we get a z-score of -1. So we transfer this information over to our graph, draw the horizontal axis. 0 is the mean, it goes right in the middle. You can draw a vertical line through your mean and then the bell shape. And then mark where z equals -1. And so for us, because we want X to be more than 60, we want to shade the area that's to the right. So then using your calculator, again, this is a standardized value now. So when you punch all this in, you are going to go the second key, VARS, and then normal CDF. For the lower bound, we want -1 because that's our z-score, and we want the area that's to the right of it or above it. So I chose a really big number for the upper bound. I chose 1,000,000, that's probably not necessary. Our mean, again, mu is 0 because this is standardized now. And then our standard deviation is 1. You can hit enter and hit enter. So the area that corresponds is 0.8413. So the probability that X is more than 60 is 0.8413 or 84%. So 84% of test results should be higher than 60. What if we change the question and said less than? It's the same first step. We still need to find the z-score. So mu is still 85, sigma is still 25. This time we get a z-score of 1. Sketch the normal curve and shade the area that corresponds. Draw a vertical line through 1 and shade the area. This time we want less than, so we shade the area to the left. And then again, you can go back to the table to find this, or you can use the graphing calculator. That's what I'm going to do. This is already standardized, and these calculators remember what you did. So if you go to second, bars, normal CDF, this time we're calculating the area that's to the left, so pick a really small number. For the upper bound this time, we want 1. And we still have the same mean and standard deviation. So you can just hit enter a few times. You should get this. Make sure you hit negative. And there you have it. Once again, we get 0.8413, or 84% is less than 110. So the next question, what is the probability that x is not less than 110? What is the probability that x is in between 65 and 110? So we are close. I mean, if you look at the questions that are right above it, we already did questions that are very similar to this. What's the probability x is more than 60? What's the probability that x is less than 110? The only thing we have to change for our z-score for the first part of this, we had to do, I mean, essentially we had to do 1 minus our z-score to get 0.8413. So now you would just want to use your formula to find the z-score for what is less than 65 or 60, sorry, not 65, 60. Or another option, you can just do 1 minus 0.8413 because this represents the area to the right. So if you do 1 minus 0.8413, you'll get what's on the area to the left. But if you'd like to use your calculator, again, you hit the second variables, second option, and again, we are going to the left. So our z-score is changing. Oops. To -1 this time. And we should get 0.1587. Okay. So what you're going to do is take the z-score of 1 minus the z-score of -1 to get your value. So for the z-score of 1, you're going to do 0.8413 minus 0.1587. And we should get a number we've seen before, but we can always just double check. And we get 0.6826. Or, because it's within 1 standard deviation of the mean, we get about 68%. Again, that goes back to our 68, 95, 99.7 rule. And to sketch that, set up your normal distribution, a nice smooth bell curve. And draw vertical lines between -1 and +1. And shade the area in the middle. All right. Good luck. Let me know if you have any questions.